Hey, welcome back, Al. This is Naresh again. Yeah, so far we have been seeing different open table formats, Delta, Hudi, and Iceberg, right? But this assume that you introduce a new query engine that is not going to support your Delta file format. Then you are what are the options left for us to is just de duplicate the data into another table with the Hudi format and then use it in the new query engine. That means your data is not a universal data. Means you cannot use the one copy of data for a different engines. So and this engines maybe the query engines or readers come up with their own limitations. So how can we make our data as a uniform universal data with only one single copy of data? So for that the one house a company behind Hudi that predominantly support the Hudi has come up with a new concept called the one table. One table is it's not a new table format. It just your existing data with a new that data will be converted between the different formats. That means you don't need to copy duplicate the data between the three different formats. You can use one single copy of data that can be shared between all other that can be converted into the other file table formats. Assume that you have a data your existing data lake or lake house you build using a Hudi, and you can use the same data same parquet file and use this one table utility to convert the Hudi data into the Delta or Iceberg format. So that means you can convert from any format to any format. It's like the omnidirectional. In any direction, you can do the conversion, and this makes your data as a single copy. And what in behind the scenes it is generating is a different metadata for the same data files. As we know that at the core wa- these table formats are like the parquet files with the extensive metadata. So they all use the same parquet data. So that's the reason this one table come up with an approach to convert one table format metadata to other use that one table format metadata and you generate a new table format metadata. That way you don't need to rewrite the copy. You don't need to duplicate your data files. So the duplicate you are not duplicating your data means your data is a universal data. The same data can be used for any engine. So that's one of the idea behind this one table format. And with this tool, what we can do is we can go and uh, uh, it requires a configuration file where you specify the source format, whether it's an Iceberg, Hudi, or Delta, and then you mention the targets format, destination format, table format. Then the tool will one table will translate the metadata from the source to your destination, whatever you have it in. So that's about the one table, and that way you can make your data as a universal data, and then you can write the data once. Your existing process that is generating this data can write the data either in any one of the format and use the one table to translate for other formats, so that your data can be available to wide variety of the query engines. That's about the one table. And so you might have heard about this delta lake uniform. So delta uniform, that's also the same thing, but that requires you to always write data in the form of a delta and then allow you to convert into the different formats, either the Hudi or the Iceberg. That's a one limitation with the delta uniform. So, but and that is governed by the Databricks, but this one table is governed by the open source Apache, so it's going to be a community driven. That's about the one table. You can find out more details in the one table.dev, and you can find read about when can we use and when can not use. So having said that one, so I would in this demo, in this video, I would likely to show or create a table in a Spark. Uh, so I wanted to show you some setup. Like I wanted to, I will create a data in the Hudi table and generate the metadata for the delta and iceberg and then read the iceberg table and read as a delta table. Let's see if we can read that data. So for that one, first I need to generate the Hudi table, right? So let me go here. So here I have some data, so I need to clean it up so that we can start freshly. Yeah. So here I have the data. So I'm going to, I have the table called the trip. So I'm going to delete it so that we don't we'll generate the new data. So I don't have anything here, so I'm going to create a Hudi table. This is a standard Hudi configuration you are seeing so far in these videos, and then I'm inserting the three dummy rows into the table and writing as a Hudi table with the table name, and this is the path of the table. Let's run this one. So this is going to generate a yeah, it generated the Hudi table with all the metadata configuration. Yeah, it's completed. Yeah, it generated the metadata of Hudi and these are the partitions that I'm partitioned by say. So you see here we have all the metadata. What we can do is we will so the one table provides a jar that the jar we can download the jar from this. You can download the code from this GitHub link and build the jar, or else you can simply go to the link. I will put it in the I'll put it in the description of the video so that you it will download a jar called uh, it will download a jar called utilities 01 beta bundle jar. So this is the jar we will use to translate one table format to other table format, and then it required some configuration file. So that configuration file I have it here. So this configuration file is a YAML file that is of the state. So here I am specifying the my table format source format is an Hudi, and I wanted the target format as an iceberg and delta, and table configurations like this is my uh, location of the table path, and this is the table name and the table spec partition spec. So just these less small amount of information we need to give it, and then so I have created those files, right? So let me go and run a program so that so this is the Java code. This is a jar, right? You can run a Java program with the configurations as the myconfig.yaml. So in this one, in the myconfig.yaml, I mentioned my uh, Hudi as a source format, and the table data is available here, table name and the partition value. So let's go and run this one. So, and before we run this one, let's go and check in the trips table. If you see here I just have the partitions and the Hudi table. So we with this one we should able to see the other tables metadata, delta log, and the metadata directories. Let's go and run it so that we can see. I'm running this one here. Okay, one table sync is successful for the following metadata iceberg and data. So if you go to this directory section, you would see the two different new folders got created. So earlier we have this Hudi and the Chennai, but now if you see this one, you see the two new directory got created. These two new directories are the metadata for the snapshot, iceberg, and the delta lake. So that means your data is now same data can be read as an Parquet Iceberg table or the delta table. So let's go and try to read that and see whether we can read this data. So for this one, I have the simple program where I set up the Spark job, and then I configure this is my Spark Iceberg catalog, and I put the warehouse directory is this one. So that's where the data is available, and I'm creating this catalog as a local. I mentioned here, so I put it here at the table name. This is my table name. So let's read this Iceberg table and see whether it is returning any row. Good, we are able to read the data. So we are reading as an Iceberg. We are reading as an Iceberg table, and we are able to query it, and it is returning the data for the uh, of the same Hudi format data can be read as an Iceberg data. So the same way we can go and run it for the Delta Lake too. So this is the same standard Delta Lake setup configurations, and then I'm reading as in a Delta file onto the same directory. So let's go and run this one. We should be able to read the 3 rows. Voila, we are able to see the three records as in a delta table too. So this way we can use our existing process that is running the data in whichever the format, either it's in the Iceberg or Hudi or whatever it is, and then we can use the same table data to convert that metadata to the other table format and use this table. This makes our table as a universal, so any query engine can read the same data without any duplication of your data. So as we know, the duplication of data create the data drifts. We don't have any data drifts here. And this community behind this one table AI is an open source, so it's the community. A lot of big companies are going to support this one, like the Microsoft, Google, Amazon. So this way you can write you can use your data in one format, and you can use either using the Delta, like Databricks, Snowflake, or any other query engine that choice of yours, without duplicating the data. That's a quick introduction about the Iceberg tables and the one table and open table formats, and leverage the one table to read the same data into the different format. Hope you like this video. Hope you like this series, and probably this is the last video in this series. And we'll go into the next level in this table format in coming videos. So hope you all enjoy this all these videos so far. Thank you.